Before we go any further, let's take a moment to really understand what a vector graphic is. Now, the term vector is tossed around a lot, especially in the world of graphics, and not everyone has a core understanding of what that means. And again, the more that you know about how Illustrator works, the better you can take advantage of its features and functionality later on. Now, when we talk about vectors, we're usually comparing it to something else called pixel-based graphics. So let's get those terms down for a minute here. We have something called pixel-based or raster-based images. Sometimes they're also called bitmaps. Those are the kinds of graphics that a program, say, like Photoshop creates. Then again, you have vector graphics or object-based graphics. Those are the kind of graphics that Illustrator creates. So let's see exactly what that means. I'm using a file here called vectorgraphics.ai. If you have access to the exercise files, you'll find it there in Chapter 1. And what I'm going to do is I'm going to go to my Layers panel here and turn on this first layer called Grid. So let's imagine just a sheet of graph paper for a moment. You have a whole bunch of basically these little squares. And if you think about it, in mathematical terms, and I know I'm not a big math person, I don't like talking about math, but that's the core understanding of what these graphics are. We are dealing with computers here. So basically, imagine you had this sheet of graph paper, and each square represents a little dot that you can color in. Now imagine you had a bunch of magic markers, and you wanted to draw some kind of a picture. And the rules of the game are that you have to fill in each particular square on that grid completely with only one color. You can't have two colors within the same box. And you also can't have a box that's only half filled with color. So every box itself has to have some kind of color attributed to it. And if you look at it right now, I would basically say that every box in that grid is filled white. This is the way that Photoshop works, or pixel-based graphics. A raster, basically, the definition of a raster would be number of boxes width and number of boxes height. So basically you can see I have a whole range of boxes from left to right here. And I also have a whole bunch of range of boxes from top to bottom. Now, going ahead and coloring each of these in, I can then create a graphic. Now, I'm going to go over here to where it says raster. I'm going to turn on the raster layer. So this is basically how you might go about creating a graphic or raster image, let's say inside of Photoshop, for example. I'm exaggerating these pixels here, but basically at the core part of how Photoshop works, you have a grid, and each of those elements or those dots inside of that grid, which we refer to as pixels, is filled with a color. And again, like we said before, you can't have a pixel that is half filled or that contains more than one color. A pixel can only contain one color. So as you see right now, I have these boxes that are filled in black. These are filled white, and these are filled with this orange color. And I'm trying to create an image of maybe a surfboard. Doesn't look that great, but that's because this particular image here has what we call a low resolution. Resolution refers to basically the number of squares that you have in your grid. So you may have heard, let's say, for example, digital cameras have something called megapixels. How many megapixels? 5 megapixels, 10 megapixels, so on and so forth. Well, basically, a pixel is the smallest dot or size of a square that you can fill in with a color. Megapixels refer to the thousands or millions of pixels, basically, that you would have in a particular image. Now, obviously, if I cram a whole bunch of pixels into an image, these boxes start to get smaller and smaller. So that would allow me to have more and more detail in my image. Now, if I would, for example, have a digital camera that had a resolution of 100 by 100, for example, or something like that, you would get very, very big blocky squares like I'm seeing right here. Now, if you have an expensive camera that has many megapixels, then of course those pixels are so tiny that the human eye doesn't really pick up on them, and therefore it appears as if it's a regular photograph that has all this continuous tone, but really down at the bottom of the core of that are each of these pixels. And the reason why that's important to us as designers or people who use graphics is that when you start to enlarge those photographs, then those pixels start to come into view. You may notice that when you're using a program like Photoshop and you have an image, that image may be set at a certain resolution. It may look great at the resolution that it was created at, but if you want to enlarge that graphic, then these boxes start to become visible. Just for example, if I zoom out for a second here, you might see that that particular piece of artwork starts to look a little bit more smoother, right? And again, this is a very low resolution just to exaggerate it. Imagine that little message on the cereal boxes that says enlarge to show texture, right? I just want to be able to, you to understand and see what this particular raster image is. But if I zoom in really close as I get bigger, basically when you enlarge a Photoshop file, it's not adding more pixels. It's basically taking those pixels and just making those pixels bigger and bigger. So now the squares just get bigger and I see them. So let's contrast this now with vector graphics. So I'm going to turn off the raster layer here in my layers panel. I'm going to turn on the vector layer. So now what I'm seeing here is the way that vectors work. Vectors are all based with math. I'm taking that exact same grid. I'm having that coordinate system basically. I have X number of boxes by X number of boxes, but instead of me actually having to fill in each of these individual pixels, what I'm doing is I'm plotting anchor points. And these boxes that I have right here are the areas where you might see those particular anchor points. And those anchor points define the area of where that shape is going to be, and you have basically a path that gets drawn through those particular anchor points. And we'll talk more about how you create those paths and the settings for what makes them curve and how much do they curve and when is it a straight line. We'll deal with that later, but for now, it's important to understand the core concept that these dots that I have right here are anchor points that are basically points plotted on a grid. And you took geometry in school. You know that when you have, let's say, a graph, you can plot a certain point, and that point has a coordinate. For example, if you have an x and a y axis, that this particular point may have a specific coordinate of x 20 and y 35 or something like that. Now, the reason why that's important is that if I decide now that I want to enlarge or scale this particular graphic, what Illustrator simply does is that it takes that math and it just enlarges that particular image or those anchor points, and it replots them and it recalculates using math where those belong on a grid. So you can basically take any graphic that you create inside of Illustrator and you can scale it to any size whatsoever. I mean, you could take something that is the size of literally a postage stamp and enlarge it to be the size to fit onto the size of a blimp, and you have no loss in detail whatsoever. There's no blockiness, no chunks. There are no pixels that come into play here. One other benefit of working with vector images is that when it comes time to actually saving your file, in general, vector graphics tend to be smaller in file size, or I guess you can say more easier to deal with. And that's again because of how these files are saved. If you think about it, the way that Illustrator saves this file from a mathematical standpoint, it just remembers the coordinates of this anchor point, this anchor point, this anchor point, this anchor point, and two attributes, which are what we call the stroke color and the fill color, and we'll talk about that shortly. But for now, basically, that's all that a particular file for Illustrator needs to be calculated by. A Photoshop document, however, needs to take account basically of every single pixel that exists in the file, whether or not it's painted or not. I mean, again, these would be white. Let's go back to the raster image for a second here. What Photoshop would need to do is memorize, okay, pixel number 1 is white, pixel number 2 is white, pixel number 3 is white, pixel number 4 is white, down the line throughout the whole particular image. And that, obviously, if you think about images that have megapixels, remember, so many more pixels in the file that it has to keep tabs on what each of those particular pixels are colored. That's when Photoshop files start to grow in size, and they get to be hundreds of megabytes or even gigabytes in size. So finally, just going back to the vector graphic here for a minute, and I'll turn off the raster layer here. Another name for vector graphics is something called object-based graphics. And again, that's simply because of the way that Illustrator works. Because this is defined as a shape by these anchor points and this particular path here, it's not like I just have a whole bunch of pixels that live in the same area. If I click on this object right now, I see that the entire object as a whole gets selected. And that's another reason why vector graphics are often referred to as object-based graphics, because I'm not working with a whole bunch of individual pixels. I'm working with an object, and that object that I'm working with can have attributes, so on and so forth. So now that we have this core understanding of what a vector graphic is, let's take a look and understand exactly what these paths are, how they're created, how they're stored, and the way that I can actually interact with them.